Hey everyone. So I've gotten numerous requests to make a tips video for the final exam. You should know first of all that because the final exam does cover material on the first two midterms, pretty much all of the content tips that I would say for that material has already appeared in a previous video. So in this video, I'm going to finish up my coverage of the content by giving you a few tips on the final unit of the course, regular languages and finite automata. So my first tip is practice writing regular expressions, DFAs, and NFAs as much as you can until you get very, very good at them. It shouldn't come as a surprise that there's going to be some questions on the final where, say, I give you a language, and then I ask you to either write a regular expression for that language, or to draw a DFA for that language, or to draw an NFA for that language. I've given you a lot of practice questions for this skill in the course notes. You can also make up questions of your own pretty easily. So please do get very, very comfortable with this skill, because ideally, you want this type of question to take under 5 minutes. And let me remind you of one tip that I gave on a previous video about regular expressions, which is if you're having trouble writing a regular expression or a DFA or an NFA for a language, then one thing you can try to do is write a regular expression or DFA or NFA for a simpler language. And by breaking down the language into simpler languages and then writing regular expressions or finite automata for that simpler language, you should be able to try to find patterns which you can use to attack the original language. So if you're stuck, solving an easier problem first is a really good strategy. On the flip side to writing regular expressions or finite automata for certain languages, it's really, really useful to know how to convince yourself that your answer is wrong. And remember, this is actually very, very easy to do, but it's a skill that's somehow overlooked a lot. If you have a language L, and then say you have some regular expression R, which is equal to something, if you want to show that R is not the right regular expression representation of L, all you need to do is give some word X that's either in the language but not matched by the regular expression, or X is matched by the regular expression but not in the language. And the same is true for any sort of DFA or NFA that you draw. If you have some string X that is in L, but not accepted by your NFA or DFA, or if you have some word X that's accepted by your NFA or DFA, but not in the language, then that means that your finite automaton is wrong. And the point that's really, really useful here is because you only need to find the one string X, usually it's pretty easy to show that an incorrect answer is actually incorrect. These were some fundamental sources of confusion that came up during Challenge 9. Some students got mixed up between strings versus languages, and in fact, on question 1 of Challenge 9, they tried to do induction on strings rather than induction on the set of all regular languages. Keep in mind that this unit here was the most terminology heavy, and so part of your studying for this unit should be being very comfortable with all the terminology, and in particular, what the difference is between a string and a language. And also, there's a very clear definition of regular languages that's given in the course notes and that we saw during lecture. Make sure you know what this definition is, because if I ask you to prove something about regular languages using structural induction, what I'm looking for is this recursive definition. If you're not clear about how the phrase structural induction goes together with the phrase recursive definition, then you need to review structural induction. When we talked about DFAs, the material got a bit more rigorous, and we saw 3 different kinds of proofs that involved DFAs. The first kind of proof that we saw was a proof of correctness for DFAs, and we were able to prove that DFAs are correct using this idea of state invariance. And remember here, state invariance are properties that characterize exactly which strings reach which states. And these can be properties that are expressed entirely in English. Like, for example, the string starts and ends with the same letter. That can be a state invariance. Or the string contains 10 zeros and 15 ones. That can be a state invariant. The next kind of proof that we saw was a proof on the number of states required by a DFA to accept a given language. And here the main ingredient of the proof was this idea of distinguishable strings. I'm not really going to go into much detail in this video because I posted a previous video about this exact topic, but maybe I'll just draw a picture to remind you of what's going on. And the third kind of proof that we saw was a proof that languages can't be accepted by DFAs and hence can't be regular. Out of all three of these, this last one here was probably the hardest kind. So when you're studying the content of this unit, I strongly recommend that you pay special attention to this one here. And maybe I'll just draw a picture again. Okay, and the last tip is something that I've talked about in a previous video as well. When you're thinking about non-determinism, and in your intuition, you're using the phrase right choice, I'd conjecture that at least a quarter of you don't actually have the right idea for what it means that an NFA always makes the right choices. So regardless of whether you think you understand this concept or not, watch the video that I posted about what the right choice actually is. Because for at least a quarter of you, it won't be what you think it means, and this will lead to some great confusion in your studying and on the final. And that's all for this video. Stay tuned for a video about some generic study tips for the final. And as usual, thanks for watching and have a great day.